Today I'm going to talk to you about a new topic which you haven't covered yet. It's called the quadratic formula, and it gives us another way of solving quadratic equations just using this standard formula which you'll need to remember. We're going to go through everything about it later on in the lesson, but to start off with, our atomization is to know how to actually substitute. So I'd like you to have a go at these questions here, please. Give yourself 5 minutes, pause the video now, and then I'll go through it. Okay, so the idea of substitution is to actually swap some unknown value, which we don't know, with something that we know. So we're going to substitute this value of 4 into A, the value of 9 in for B, and the value of -5 in for C. We end up with this by making it look nice. 4 times 9 is 36, add 24 gives us 60, and 2 times -5 is -10. We end up with a value for this expression, which would be -6. Likewise over here, we can use actual formulas we use in maths. So this is for the area of a rectangle, is 2 times the width plus 2 times the length. So 30 times by 2 is 60, add 11 times by 2 is 22, 60, add 22 is my area, which would give me 82. And lastly, this is a formula for kinematic equations, where we can work out my final velocity, and sometimes we're not asked to work out what we're equal to. We can sometimes have to use solving equations to work out some unknown in the middle. So this first one, u equals 23, a equals 4, and t equals 3. By using this, I know that v equals 23 plus 4 times 3. 4 times 3 is 12, plus 23 is 35. But looking at the next question, I know what v is now. So I have to do 30 is equal to u plus 2 times 8. So therefore, from here, 2 times 8 is 16. What do I add on to get to 30? It must be 14. And finally, I know that 40 is going to be equal to 12 plus, well, AT is 4t. Well, 40 take away 12 is 28, and that's going to be equal to 4 multiplied by t. So therefore, my value of t must be equal to 7. Well done if you got those. I want you to just take a moment to mark them and check them. And then we're going to move on to actually factorising quadratics. Now, this is something we've done previously, and we've done it quite a lot. So what I'm going to do is just write down a quadratic. This is going to be in my example that I'd like you to write down. X squared plus 7x plus 12. And we're going to look at how we factorise this. So, in order to factorise this, I'm going to look at my coefficient of x and my constant term. And I'm going to tell you that we need two numbers that add together to make this, and multiply together to make 12. So they add to make 7, and they multiply to make 12. And thinking about these numbers, the only ones that I have, well, 12 is 1 and 12, they don't add to make 7. I can have 2 and 6, they don't work. 3 and 4 does. So therefore it's going to have to be 3 and 4. And because it is monic, there is no coefficient of x squared, I can simply just do x add 3, x add 4. So we've done quite a lot of this, so what I'd like you to do is have a go at these questions, and I'd invite you to have a look at these really tricky questions at the end, especially for those students who are finding these a bit routine. Okay, so moving on from here, I'm just going to show you the answers. So for the first one, x squared plus 4x, what we should get is x plus 3, x plus 1, and then I'd like you to pause the video now to have a look at the answers and just mark where you've got, and if there's any errors, just please correct them. Okay, so moving on then, why do we need this formula? Well, I'd invite you to have a go at trying to factorise what this problem is. So, I'd like you to pause the video now. I'll just give you sort of 30 seconds. And what we should find is that we're looking for two numbers that add together to make 2, but multiply to make -5. The only numbers I know which multiply to make -5 are 5 and 1. Well, or -5 and 1, or -1 and 5, and they don't add together to make 2. So I can't actually factorise this. We have looked at a method to actually work this out. So if I wanted to work this out, I could use that completing the square. So therefore I halve my value, my coefficient of x, to get x plus 1 squared. I take away 1, because that's what 1 squared is. Take away 5 equals 0. And then if I solve this, I get x plus 1 squared is equal to 6 because I've added 6 across. Square root of that is x plus 1 equals root 6. And then take away 1, so that should be plus or minus. Take away 1, I get x equals negative 1 plus or minus the square root of 6. Now, this is a method that we know how to do. However, it's quite complicated to do and it's a bit laborious, and honestly, it's not really that useful for solving equations. So what we do is we think about a general case. Now, this is something that I'd like you to write down. So we start off with the equation ax squared plus bx plus c equals 0. And if we have this equation, then we get the quadratic formula, which is written here. X equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. So I'd like you to pause the video now just so you can write down everything in this black box here. Okay, and I'm just going to show you where this comes from, but you don't need to remember this, you don't need to memorize it at all. You just need to know what this formula is. So, going through how we actually get to this formula, we just complete the square on this. So the first thing we need to do is get rid of this a term in front of x squared, so I divide everything by a. Again, I don't want you to write this down, I just want you to know that it does come from somewhere, rather than just something that Mr. Bedford has made up. The next thing I do is complete the square, so therefore I need to halve this coefficient of x, so it'd be over 2a. And then what I do is I think about getting all of this term onto the other side. So I've just added b squared over 4ac and taken away c over a. What I can then do, looking at this, is trying to simplify it a little bit on this right hand side by getting a common denominator. As this is squared, I square root it, and then I take this b over 2a across, and I end up with this formula. Again, I must stress, you do not need to know how to do this step. However, it's important to know that it comes from somewhere. What you do need to know is how to apply this formula. So, make sure you've got this down. The first tip I will tell you is that you have to have your equation equal to 0. So looking at this example here, I'd like to write it down. X squared minus 3x minus 5 equals 0. It is equal to 0, so therefore I can use this formula. If it wasn't, I'd have to move it across to the left-hand side by either doing the inverse operation, so adding it if it was negative, or subtracting it if it was positive. Okay. The first thing I'm going to do, I'm going to look at my equation, and I'm going to compare something called coefficients. So, do I have a value of a? Well, it's whatever's in front of the x squared. So in this scenario, my a would be equal to 1, because there is 1x squared. My value of b is the coefficient of x, which would be negative 3. Because this before the x is negative 3. And lastly, my value of c would be equal to negative 5. This is important to actually write it out, and you know you're going to have to use the quadratic formula whenever it tells you that its answer is to 3 significant figures. So the next step is to actually substitute it in. So in order to substitute it in, all we do is we just replace my letters in here with my values here, like we did in the starter. So x equals, and it's negative b. Well, if b is negative 3, the negative of that is positive 3, plus or minus the square root, and it is a b squared, so negative 3 squared, take away, and I would always put this 4ac in brackets, so 4 times 1 times negative 5, and that is all divided by 2a, which is 2 times 1. Make sure you're writing this in. From here, I just make it look a bit prettier because it's quite ugly at the moment. So I'm going to sort out what's on the inside. So I've got 3 plus or minus the square root of, well, negative 3 squared is positive 9. Take away, 4 times 1 is 4, times negative 5 is negative 20. So if I'm taking away negative 20, that's adding 20, all divided by 2. I'm just going to pause here so that you can actually catch up with me and write it down. And then what students are often confused with is this idea of plus or minus, but all I'm going to do is just rewrite this as two equations. I'm going to say that x is equal to 3 plus the square root of 29 over 2, and x is equal to 3 take away the square root of 29 over 2. Once I've got to here, I'm going to just work it out on my calculator by typing it in, and I will get the answer of 4.1, well, it's three significant figures, so 4.19, and it would be negative 1.19. Check you can type that on your calculator and get the same answers, but this is essentially as hard as the quadratic formula gets, but the difficulty is knowing that you need this formula. So, what I'm going to do is just going to quickly show you some questions that I'd like you to have a go at. So, here are some questions here. X squared plus 5x plus 1, x squared minus x minus 1. I'd like you to make this table. I'd like you to write down explicitly the values of A, B, and C, and then work out the solutions to three significant figures, please. Pause it now, probably 2-3 minutes a question after you've got the table down, so maybe 10-15 minutes to have a go at these questions. Okay, and just to check that we're all on the same page, this is the answers to the first question. Just verify that you've got the same ones as me, please. That'd be great. And then the answers to everything else are written here. This bottom equation has no solutions, and you would just simply state that it has no solutions. You'll probably get a maths error on your calculator, and that's okay, that happens. Okay. So, that would be the first type of question. The next type of question is a show that question. So here, I need to actually show what my formula could be from a scenario. So here I've got a trapezium. It says the diagram shows a trapezium which has an area of 17 centimeters squared. Show that 2x squared plus 7x minus 17 equals 0. To answer this, I'm only given one bit of information. I'm given the area of a trapezium is 17. I'm just going to write that down. My area is going to be equal to 17 centimeters squared. But looking at this trapezium, I've got some length, so I could work out the area myself. The area of a trapezium is base, the two base angles, so x, add x plus 7. So we add them together. They're my base angles, and we have to halve it because I want the average length. And then I multiply by the height. If you're not sure of the formula, it's a plus b over 2 multiplied by h, where a and b are parallel sides, which are given here. So expanding this, I get 2x plus 7 over 2 multiplied by 2x. Well, these two 2's are going to cancel, so I get x lots of 2x plus 7, which will give me 2x squared plus 7x. But now thinking about my scenario, I have two formulas now for the area of a trapezium. I have got that the area is 17x and the area is 2x squared plus 7x, so therefore they must be equal to each other. So 2x squared plus 7x must be equal to 17. So if I take away 17, I get 2x squared plus 7x. Take away 17 equals 0, and hopefully this is what they wanted me to get. So this is my final stage for the show that question, and that'll be worth 4 marks. The next step is to just solve it. So all I do from here is I say that A equals 2, B equals 7, and C equals negative 17. And then I use my formula. My formula I'm going to write down over here. X equals negative B, so negative 7, plus or minus the square root of B squared. So 7 squared, take away 4 times 2, because that's a, times by negative 17, divided by 2a, so 2 times 2. I'm going to put that into my calculator now. I'm going to do it twice because I've got 2 answers. I've got it where I add it on, and I've got it where I take away. So therefore that gives me the answer of x equals, let me just drag down so you can see, x equals negative 7 plus the square root of 185 over 4, which is 1.65, I hope, and x equals negative 7 take away the square root of 185 over 4, which is negative 5.15. Okay, that concludes the bulk of the teaching, so I'd like you to just think about how we could do this for some example questions on the next page. So make sure you've got your quadratic formula somewhere you can look at, make sure you've got a calculator and you know how to substitute incorrectly, and on this page I'd like you to have a go at these questions. So I'd like you to write down the question and then work out how we could actually get the solutions to 3 significant figures, please. So pause the video now. This should maybe take 15 to 20 minutes. Write down the questions and have a go. Remember, for f, g, h and I, it needs to be a quadratic which is equal to 0. Okay, so I'm just going to run through some answers. So this first one we should get negative 1.62 or 0.618. And then just running through. For this one, you'd need to expand and then take away 4. Expand and get it to one side. And for this bottom one, you'd need to multiply through by x. So you'd get x squared minus 1 equals x, and then you could do it from there. Well done if you managed to get onto question 2 and 3. And then I think there's one more thing. If I have a question which is 2x squared minus 7x minus 3 equals 0, what I'd like you to do is solve it, and then I'd like you to also make a note of what mistakes students would make. So I'd like you to have a go at trying to solve it now. So you can pause the video and have a go. Okay, you should get that a equals 2, b equals 7, and c equals negative 3. Sorry, b equals negative 7. When we substitute it in, we end up with this. So my 2 answers are 3.89 and negative 0.386. The first mistake I think students are going to make is that if b is negative, they would put a negative 7 at the front, rather than realising that it's the negative of b. Negative of negative 7 is positive 7. The next step is when squaring a negative value. Here, for this 49, they might get negative 49. And finally, when doing the negative 4ac, they might actually do the subtraction rather than adding it on. So thank you for watching. There is a worksheet now that you can have a go at if you have time, and I'll see you hopefully soon.